Hello all, welcome to the Counting Well RMS Prep live session. We know that the baseline for RMS, that is Ramanujan Math Scholarship, is already released and we have the final assessment test on 30th April. How to participate? You just have to complete the course in step 1 of the RMS in order to qualify and take the scholarship. We have designed the course to help the students fill any learning gap from previous academic year and get the students prepared for the new class. So we are here to help you qualify the scholarship. For this, stay tuned to the session and get ready for the test. In this session, I will take you through the chapters, number system, fractions and decimals, and data handling. But before that, let us discuss the question or the problem posted by our app user Vartika Chawla from Kalka Public School from the chapter Fractions and Decimals. Let us help her by solving this doubt. The doubt is a word problem. Total enrollment of a school is 840. Out of this, 2 by 7, it is a fraction, are girls and rest are boys. Find the fraction of boys in the school. Also find the number of girls and the number of boys in the school. Let us try to solve this problem. What is given? The total enrollment of a school, which is 840. So we have total number of students in the school as 840. First, we have to find the fraction of boys in the school. So we are subtracting the fraction of girls from 1 as we consider total or whole as 1. So we'll subtract fraction of girls from the number 1. Given is fraction of girls, which is 2 by 7. So if we subtract 2 by 7 from 1, we get 5 by 7. So fraction of boys is 5 by 7. Now that we have to find the number of girls and number of boys, we know 2 by 7 of 840, that is total number of students are girls. So we just have to multiply 2 by 7 and 840. So the number of girls will be equal to 240. Now, how will you find the number of boys? We know the total number of students is 840. So we just have to subtract 240 from 840 to get the number of boys, which is 600. I hope, Vartika, your doubt is cleared. Let us move towards our chapter, number system. What are integers? So integers are nothing but collection of positive numbers, negative numbers, along with the number 0. Okay. When do we use integers? Integers are used in many situations when we need to represent two opposite or contradicting situations. Let us compare two integers using a number line. Let us see how integers are positioned on a horizontal number. So we can see positive integers are placed on the right side of 0, whereas negative integers are placed on the left side of 0. We know 0 is neither positive nor negative. Let us see one example. So as I told you, integers to the left are always less than the integer to the right. So 0 will be less than 1, but 0 will be greater than -1. That is, integers to the left of number line is less than to those on the right. But if we draw a number line vertically, then integers at the bottom will be always less than the integer on the top. Because we are going to take positive integers on the upside of 0 and negative integers on the downside or the lower side of 0. Let us see one example. Numbers 1 and 4. If we plot number 1 and 4, what do we see? 1 is to the left side of 4. So we have 1 is less than 4. Now take the integers minus 2 and 3. Minus 2 is negative integer, 3 is positive integers. Minus 2 is to the left of 3. So minus 2 will be less than 3. In general, if we are not using a number line, negative integers are always less than positive integers. 0 is greater than all the negative integers and 0 is less than all the positive integers. But if you are comparing two negative integers, for example, minus 2 and minus 3, which one is smaller? Minus 3 will be smaller number. Why? Because in negative integers, what happens is we take into account the value of the number. So as we know, 3 is greater than 2, but as we are dealing with negative integers, 3 will get smaller than 2 along with minus sign. So when we are talking about minus in minus 2, minus 3 will be less than minus 2. Let us see how do we add integers using a number line. Suppose we want to add integers 2 and minus 5. The first step is to draw a number line. So here we can see we have a number line. We have to mark 2 on the number line. So where is 2? 2 is 2 units right side of 0. Then we have to start from 0 and move 2 steps forward to reach the position 2. Then from 2 we have to move 5 steps backwards. So the sum of 2 and minus 5 is minus 3. So whenever you are adding a negative integer, here the negative integer is minus 5. When you are adding negative integer, we are moving backwards in the number line. So in this way, we add the integers 2 and minus 5. So the conclusion is, whenever we are adding a positive integer, we have to move forward. When we are adding a negative integer, we have to move backwards. When you are adding integers without using number line, the rule is if the integers are of the same sign, means either the two integers are positive or the two integers are negative, then you have to add the integers and keep the same sign. Let us see one example for this. Adding minus 4 and minus 3. Minus 4 and minus 3 both are integers with same sign, which is minus. Or we can say both are negative integers. What you are going to do, you are going to add 4 and 3, which is 7. And we have to keep the same sign. Both the numbers have negative sign, so 7 will be negative. So we have minus 4 plus minus 3, which is minus 7. What if the integers are of different sign? We have to subtract and keep the sign of greater number. So for example, here we have one positive integer and one negative integer. So we have minus 8 and 2. Just subtract 2 from 8, you will get 6. What is greater number here? Minus 8 and 2. So you can see 8 is greater than 2. So we have to keep aside the signs whenever we are finding the greater number. So if you have minus 8 and minus 16, for example, or if you have minus 8 and 16, the greater number here is 16. If you have minus 8 and 1, Greater number here is 8. So you have to keep aside the signs whenever you are deciding the greater number. So here minus 8 and 2, among these two numbers, 8 is greater. Sign of 8 is minus, so we have minus 8 plus 2 as minus 6. Let us see how to subtract integers using number line. For example, if you want to subtract a negative integer from an integer, suppose it is minus 5. So subtracting minus 2 from minus 5. First, what you have to do, you have to locate minus 5 on the number line. To locate minus 5, we have to start from 0 and move 5 steps backward to reach the position minus 5. Then from minus 5, you have to take 2 steps forward. So minus 2 from minus 5, the difference is minus 3. Which rule have we followed? Whenever you are subtracting a negative integer, then we have to move forward on the number line. As I told you, to subtract a positive integer number line, we have to move backward. But if you are subtracting a negative integer, you have to move forward. Subtraction of integers. So without using number line, how can you do subtraction? If you know what is additive inverse, then you can subtract integers by using this statement. What does the statement says? The subtracting integers is same as adding the additive inverse. So what is additive inverse? Additive inverse of an integer is a number when added to that integer gives you the resulting sum as 0. So when you are subtracting b from a, it is same as adding the additive inverse of the number which you are subtracting. So consider two integers a and b. And if you want to subtract b from a, it is same as adding the additive inverse of b. So a minus b is nothing but a plus additive inverse of b, which is a plus minus b. Let us see one example. Let us find the value of minus 4 minus 16. So here what is a? A is minus 4 and b is 16. So what we are basically doing? We are basically doing a minus b. We know a minus b is same as a plus minus b. That means adding its additive inverse. Let us see the solution. Additive inverse of 16 is minus 16. So we know subtraction of two integers is same as addition with additive inverse. So we are going to add the additive inverse of 16 to minus 4. So minus 4 minus 16 is minus 4 plus minus 16. By the rules of addition, we have to add the numbers and keep the sign. So both are negative integers. So add 4 and 16, it will be 20. As both the integers are negative, we'll give negative sign. So minus 4 plus minus 16 will be minus 20. Now let us go to our next chapter, which is fractions and decimals. What are types of fractions? Based on the numerator and denominator, whether numerator is less than denominator or the denominator is less than numerator. So proper fractions are the fractions in which numerator is less than the denominator. So the value of that fraction will be less than 1. For example, 7 by 8, 3 by 4, 1 by 6 are all of the examples of proper fractions because they are less than 1. What is improper fraction? The numerator is greater than the denominator. So the value of the improper fraction is greater than 1. For example, we have 5 by 4, 10 by 7 and 11 by 6. These are proper fractions as they are greater than 1. What is mixed fraction? It is nothing but the combination of a whole number and a fraction. Value of a mixed fraction is greater than 1. Let us see some examples. 1, 1 by 3, 2, 3 by 5 and 11, 5 by 6 are mixed fractions as they are greater than 1. What are like and unlike fractions? We can categorize fractions as like and unlike according to whether they have same denominator or they have different denominators. So like fractions are fractions having same denominator. Here we can see the examples 1 by 8, 2 by 8, 3 by 4 by 8 up to 7 by 8. These are all like fractions because they have the same denominator here 8. Let us see some examples of unlike fractions. Unlike fractions are fractions having different denominators. So 7 by 8, 3 by 4 and 1 by 6. These three are unlike fractions because none of them have the same denominators. Let us see how to convert improper fraction to mixed fraction. So the first step is to perform a long division. Means you have to divide by identifying the quotient and the remainder. Then you have to write the mixed fraction as quotient remainder upon denominator. Let us see one example. Let us convert the improper fraction 117 by 8 to a mixed fraction. You can see 117 by 8 gives you value greater than 1. So it is an improper fraction. On dividing 117 by 8, you will get one quotient and one remainder. So here we have 8 ones are 8, then 11 minus 8 you will get 3. We'll take 7 here. So we have 8 fours are 32 and the remainder is 5. So how we are going to write 11 by 117 by 8? You should observe the quotient. The quotient here is 14, the remainder here is 5. So 117 by 8 has 14 whole and 5 by 8 fraction more. So how we are going to write it as mixed fraction? Just write the quotient. Quotient is 14. Then write the remainder and it should be divided by denominator. So we have 14 5 by 8 is equivalent to or it is equal to 117 by 8. This is called mixed fraction. Now let us see vice versa how to convert mixed fractions into improper fractions. If the mixed fraction is of the form quotient remainder upon denominator, its improper fraction can be obtained as follows. You have to multiply the quotient and denominator and then add this product to the remainder. So quotient into denominator and add to remainder. This is what we are going to do. Then we have to write this result in the place of numerator. The denominator will be kept same. Let us consider one example for this. Let us find the improper fraction of the mixed fraction 5 by 7. Students often do the common mistake that 5 by 7 is nothing but 5 into 5 by 7, but this is not the case. This represents a mixed fraction. So to find the improper fraction, you have to identify first the quotient and the remainder. We know this will be the quotient, this is the remainder. So we are going to multiply the denominator by the quotient. So let us do that. So multiplying quotient by denominator, you have 35. You have to add this to the remainder. We see remainder here is 5. So it will be 40. The denominator here is 7. You can see the denominator here is 7. So you have to keep the denominator same. So this is how we have done 5 into 7 plus 5 divided by 7. So this will give you the improper fraction of mixed fraction 5 by 7 as 40 by 7. Let us move to our next topic, comparing like fractions. We can compare like fractions by directly comparing their numerators. Let me revise what are like fractions. Like fractions are fractions having same denominators. As the denominators are same, what is left for comparison? Numerators. So the fraction having greater numerator will be greater. Let us see one example. Let us compare 23 by 9 and 17 by 9. The given fractions are like fractions. As we can see, they have same denominator. So let us compare their numerators. 23 is greater than 17. So what do we have? 23 by 9 will be greater than 17 by 9. We can compare unlike fractions also, but for that you have to follow the steps. First, you have to find the LCM of the denominators of both the fractions. Then you have to convert each of the fractions as an equivalent fraction with the same denominator as the LCM. This will give you all the fractions as like fractions. Now the comparison becomes easier because you just have to compare the numerators of the equivalent fractions. Let us see one example. Let us compare the unlike fractions 5 by 6 and 13 by 15. These two are unlike because they have the different denominators. Now we have to do both the denominators to be same. We have to find their equivalent fractions by finding the LCM of the denominators of the given fraction. So the first step is to find the LCM of 6 and 15, which is 30. Now to get 30 in the denominator, what we are going to do? We are going to multiply the numerator and denominator by the same number 5 for the first fraction. So 5 by 6 will become 25 by 30. Same for the second fraction. 13 by 15, you have to multiply the numerator and denominator both by 2 so that you get 30 in the denominator. So we have 25 by 30 and 26 by 30. Then as we have the two like fractions now which are equivalent to the given fractions in the question, we can compare the numerators. So we can see 26 by 30 is greater than 25 by 30 as 26 is greater than 25. So 26 by 30 is nothing but 13 by 15 and 25 by 30 is nothing but 5 by 6. So we have compared the fractions given in the question. So this should be your final answer. 13 by 15 is greater than 5 by 6. Now, let us see how to add two or more unlike fractions. Adding two or more like fractions is very simple. You just have to keep the same denominator and add the numerators and write the resulting sum as a numerator of the resulting sum. But when you're comparing unlike fractions, what we are doing, we are converting them to like fractions so that comparison becomes easier. Same we are going to do when we are going to add unlike fractions. So adding fractions is allowed only when the denominators are same. So for that purpose, we need to find the LCM of the denominators and then we have to convert each fraction into an equivalent fraction with denominator as the LCM obtained. And then we are going to add the fractions by adding the numerators. If it is asked to find the answer in mixed fraction form, then you have to convert it into mixed fraction. Let us see one example for this. Let us find the sum of 2 by 3, 5 by 6 and 4 by 9. You can see the denominators of three fractions are different. So the first step is to find the LCM of 3, 6 and 9. So let us first find the LCM of the denominators. It is nothing but 18. LCM is nothing but the least common multiple. So the least common multiple of 3, 6, 9 is 18. Now we have to convert each fraction into equivalent fraction with denominator 18. So see here, we can see 2 by 3, 5 by 6 and 4 by 9 as the fractions given in the question. As you want to do the denominator same for all the fractions. So to convert 3 into 18, you just have to multiply 6. So same you have to do for the numerator also. Again here, you have 6 in the denominator, but you want 18. So you have to multiply by 3. Same number to be multiplied in the numerator. And same for the third fraction. If you multiply 9 by 2, you will get 18. So you have to multiply 2 in the numerator. So you have 12 by 18, 5 by 15 by 18 and 8 by 18. So you can see these three are the like fractions. Now our task has become simple. So 12 by 15. So 12 by 18 plus 15 by 18 and 8 by 18. If we add these three fractions, we have to add the numerators and keep the denominator same. So we have 35 by 18. If you want to convert it into mixed fraction, you just have to divide 35 by 18. Write the quotient here and the remainder here. And keep the denominator same. So in this way, you can have 35 by 18 is equal to 117 by 18. So this is your final answer in the mixed fraction form. Now that we have seen how to add unlike fractions, in similar way, we can subtract two unlike fractions. Steps are same. You just have to find the LCM of the denominators and you have to convert each fraction into equivalent fraction with the denominator as the LCM obtained. Then you have to subtract the fractions and convert it into mixed fraction if required. Okay. So let us see one example. 6 by 7 minus 5 by 12. Difference of unlike fractions because denominators are different. 7 and 12. First step is finding LCM. So LCM of 7 and 12 is 84. So we have to convert each fraction into equivalent fraction with denominator 84. So 7 should be multiplied by 12 to get 84 here. So multiplying numerator also by 12. 12 should be multiplied by 7 to get 84. So 7 should be multiplied in the numerator as well. So we have 72 by 84 and 35 by 84. Let us take the difference of the equivalent fractions, which will give the difference of the original fractions as well. So 72 minus 35 is 37 by 84, keeping the denominator same. So 6 by 7 minus 5 by 12 is 37 by 84. Now let us write and understand the decimal place values, that is 10th, 100 and 1000th. We know decimal number has a decimal point and the number to the left side of decimal point is the whole part, whereas the number to the right hand side is the fraction part. So as we move further to the left side of the decimal point, every place gets 10 times bigger. So first place is ones place, then comes the tens place, then hundreds place, then thousands and 10,000. So you can see the digits are getting 10 times bigger as we are going to the left side of the decimal point. Whereas the first digit after the decimal point represents the tenth place, means 1 upon 10. The next digit after the tenth place represents the hundredth place, means 1 upon hundredth place. And the digit after hundredth place represents the thousandth place, that is 1 upon thousandth place. As we move to the right of the decimal point, every place gets 10 times smaller, because here we can see tens place is 1 by 10. The next digit after tens place is hundredth place, that is 1 by 100. So we are getting 10 times smaller place as we are moving to the right side. To understand this properly, let us take the number 238. So in 238, 8 ones, 3 tens and 2 hundreds are there, because 8 is in the ones place, 3 is in the tens place and 2 is in the hundreds place. So this is quite simple. The place is getting 10 times larger, because here you can see it's in one place, then tens place means 10 times greater than 8. So the place value of 3 is 30. Here we have 8 and here we have 200. Let us see for a decimal number. You can see 200 plus 30 plus 8 is 238. Let us see for a decimal number 238.56. So here you can see again 8 is in ones place, 3 in tens place and 2 is in hundredth place. If you see to the right side of the decimal point, we have the tens place and the hundredth place. So on the left of the decimal point is a whole number. So on the left side we have 238, which is a whole number. Whereas to the right side, we'll see what are the numbers. First, let us discuss for the whole number. 8 is at the 1 place, 3 in the tens place and 2 at the 100th place. 5 is at the tens place and 6 is at the 100th place. So let us see the decimal place value chart. I will give you a few seconds to read this chart. Okay, so what is the chart showing? To the left side of the decimal point, we have ones, tens, 100,000, 10,000, 100,000s, and millions. To the right side of the decimal point, we have 10, 100,000, 10,000, 100,000s, and millions. Now, let us convert decimal numbers to fractions and represent them in the lowest form. For this, we follow the steps below. First, you have to expand the given decimal as a sum of tens, ones, tens, hundreds, and then you have to solve. Next, you have to simplify the fraction to its lower form by dividing it by the greatest common factor. Let us see one example. Let us convert 12.8 to the fraction form and represent it in the lowest form. So first, 12.8, it has 1 tens, 2 ones and 8 tens. So place value of 1, 10, place value of 2, 2, place value of 8, 8 upon 10. So adding this, we have 12 plus 8 by 10. So you know how to add unlike fractions. So we have here 12 by 1 plus 8 by 10. LCM is 10. So multiply 12 by 10 and you get 120. 120 plus 8 is 128. Now the next step is to simplify it. So 128 by 10, both are divisible by 2. So we divide both the numerator and denominator by 2. So you get 64 by 5. Note that it is improper fraction. So we can write it into the mixed fraction form by dividing 64 by 5. So we have 12 5s plus 4, which is 64. So we are writing denominator and quotient and remainder here. So in this way, 12.8, which is a decimal number, is converted to a fraction in the lowest form, that is 12 4 by 5. Now let us revise our next chapter, which is data handling. Let us see how to draw the tally marks table for the given information. We use the following steps to make tally marks table. First step is to arrange the data in ascending order. Next is to count the number of observations for each data. And then we have to draw the table. Let us see one example. Anshika is asked to collect the data for the size of shoes for all the students in her class. Her findings are recorded in the manner shown below. So here is the recordings or the data for the size of shoes for all the students in Anshika's class. What do we have to do? We have to represent the data of students having the shoe size using tally marks table. Why do we use tally marks table? It is one of the way to represent the data in suitable form or easy to understand form. What is the first step? First step is to arrange the data in ascending or descending order so that it becomes easier for you to draw the tally marks table. So let us arrange the data. While you are arranging the data, you have to be careful so that you don't miss any data observation when you are arranging it in the ascending or descending order. Any order is fine, but usually we use ascending order. So you can see here the smallest observation is 4, whereas the largest observation is 9. So check how many times 4 occurs. So 4 occurs 1, 2, and 3 times. What about 5? 5 occurs 1, 2, 3, 4, 5, 6, 7. So 5 is occurring 7 times. Have I missed any 5 here? Let us check once again so that you don't miss. Then we have 6, 1, 2, 3, 4, 5. Then we have 7, 1, 2, 3, 4, 5. At the last you have 8 and 9. 1, 2. 2 times 8 and 1 times 9. So count the number of observations here also and the number of observations in the question. If the total number are same, then you have not missed any observation. Next, we have to draw the tally marks table. This is the final step. So from the data, we can see how many times 4 occurs. It occurs 3 times. 5 is occurring 7 times. 6 is occurring 5 times. 7 is occurring 5 times. 8 is occurring 2 times. And 9 is occurring 1 time. Okay. 4 is occurring 3 times. So you have to put 3 marks here. So 3 vertical lines. It will show you 3 students having shoe size 4. So this is how we represent the data in tally marks. Then shoe size is 5. The number of students or the frequency is 7. So we have a set of 5 here shown by a tally mark. As shown here, we have 4 vertical lines and one slanting line from left top to the right bottom. Then we have shoe size 6. How many students we have wearing shoe size 6? So we have 5 students. Then we have shoe size 7. And the number of students having shoe size 7 is 5. Shoe size 8, there are 2 students, so 2 vertical lines. For 9, we have 1. Also, if you add this number of students, you will get the total number of students equal to the number of observations given here. In this way, you can check whether the tally marks table is correct or not. I hope this session was helpful. After Ramanujan Math Scholarship also, you want to continue Counting Well app to keep learning maths, practice and improve scores and develop good problem solving skills, then you can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well. We will see you in our next live session on 27th April at 6:30 p.m. with chapters geometry, mensuration, algebra, ratio, and proportion. Until then, keep learning, keep growing, and all the best for RMS assessments. One more thing I want to inform you all is you should complete the course at the earliest to qualify for the final scholarship test. So thanks for joining the session. We'll see you in the next session. Thank you.